is the air of product engineer and artist. When we use the engineering strategy and execution across mobility.
So this or the downstream, right? How do you want to, right? How do you want to, the last, so the last, so your, so these are example of business your, so these are example of business requirements. What we mean by business, so these are example of business requirements. What we mean by business requirements, what we mean by business requirements is see yourself as a software engineer. So I tell you the software engineer. So I tell you that I want to be. So what happens is that you're going to sit down with your clients, right? And then tell him how do you want it? What's the journey of your customer called technical specs, right? Of your customer called technical specs, right? So your technical specs are what you are now going to feed into your code, right? So it's from business requirements to your technical specs before it gets to your code. So this particular process, I can tell you that sometimes in a Scrum environment, right, this could take you 24, 48 hours to complete. But if I feed AI a technical requirement, it's going to do that for me in a technical requirement. It's going to do that for me in seconds, right? Generate draft architecture diagrams. Architecture diagrams is like a visual representation of how your system works, right? So if you want to say from the goes to maybe create an order. I'm giving an example of an e-commerce website. So that's what architectural diagrams are. Yeah, I can help you generate that in seconds, right? Boilerplate and scaffolding. Boilerplates are, so today if you want to code, you have to like create folders. Oh, this folder is for my models. This folder is for my helpers. This folder is for this. Just AI will do all that for you. Boom. In 3 seconds. Explain cryptic errors. I'm very sure you know there are some errors that don't look like English sometimes when you are coding, right? So just copy it, highlight it, dump it inside AI. AI itself will try to be like, okay, let me say something. So as you and AI are dialoguing, you now know that, oh, this thing, this is what it is. Summarize unfamiliar repo sections. So if you are coming into a new code base, for example, you don't understand what's going on there. They just employed you today. You started working, and they tell you that they need something tomorrow morning to be churned out, right? and then you look at the code base, you see 1,000 folders in the use case of AI. It's just telling you documentation. You have to generate documentation for what you do so that the next engineer knows where you stopped. Some interesting statistics that you might love to see. So DX is a platform that does 135,000 plus developers across 435 companies. So they now find that 41% the seniors do the architecture for us in a week, right? It's a lot. Trust me, it's a lot. If I can save 1 hour from the work I do, I'll be happy. Save that we have available today. So the codes that are being merged into higher throughput for your PR to your senior to approve, right? 60% of those PRs, you've been using AI to generate code and they are rejecting it. It means there's something wrong there, right? So for better code maintainability, you know what we call maintainability. That is, your code is something that can scale, right? It's not something that another person comes and they are finding it, hard to continue. So AI is able to generate better code, and 90% less time loss. So this is just some interesting stats to see how AI is being adopted and the impact it's having, amongst developers. So now, becoming AI native, right? We've spoken about who an AI native engineer is. How do you become this AI native engineer, right? Why do you need to shift to being an AI native engineer? My other colleague who spoke earlier, spoke something about AI replacing. No, AI does not replace, but those who know AI will replace who don't know AI. Sounds the same, right? But that's the reality. So there's a mindset, there are skills and there are patterns. And also, how can we integrate AI deeply into your day-to-day engineering work? So why this shift? Of course, it makes you 2x, 10x productive, right? It makes you very, very productive. Like we highlighted, there are so many things you do on a daily basis as a software engineer, right? Down from your planning, your research, your architecting, you write your tests, you deploy, AI is present in all of this, and it, of course, makes you 2x, 10x productive. So another thing why this shift matters is it focuses on high-level problem solving. Now, it's switching your role as a software developer, right? You are not like the manager. You are not the one doing the low-level code anymore, right? So you are not a supervisor. You are the one giving it specifications, like prompting it to do this, do that, do this. So at that point, right, you are now thinking about the customer. High level on it. I was using Notepad++, and I think the best thing that came out then, and that was the best thing that came out then, and that was how old people. Of course, those kind of repetitive time-consuming recalling now. Repetitive time-consuming recalling now. Weber. All right. Weber. All right. So I go around Stack Overflow, all the pages. So I go around Stack Overflow, all the pages. I didn't find the thing. All the pages. I didn't find the thing. Pages. I didn't find the thing. Advance in evolving tech landscape. Advance in evolving tech landscape. Like I said, if advance in evolving tech landscape, like I said, if you don't adopt AI, you can be buzzword scared. That's like a fear-driven approach. So the next one, but for an AI native engineer, the expectation for you to think of AI is, how could AI help me do this faster, better, or differently? You know, so that's like opportunity. You're seeing AI as an opportunity for you to, enhance your career. So view AI as a collaborator, not a competitor. Embrace continuous learning and adaptation. AI tools and models are evolving. Before you know now, there are other LLMs, just like you have spoken now. The popular ones, we have your Cloud, you have your Codex, the one from Twitter, what's the name again? Grok, I think there's another one I saw inside Copilot now. So a lot of them are coming out. And the thing, you need to use these things but to know, oh, this one works for me, this one works in this place, right? So now, the mindset now, another mindset is that you need to shift to a higher level, like we spoke earlier on. An AI native person, your position is changing, right? You are now shifting to a higher role. You become the director of your AI, right? You are giving it intent, direction, and oversight. So your own value, right? So when we talk about someone adopting AI, your value now lies in specification, right? So how are you able to specify so that AI is going to generate what you actually expect? So okay, we'll get there to see how that works. Design, quality, and verification. Yeah, lastly, very important. Trust but verify. Trust but verify. So you have prompted AI, I need to create authentication. 10 files have generated code, and you just into you, right? So AI, so as you are, right? So you get to a point where you are very, very, very sure. But before you get there, you need to do the what? Trust but verify. Okay. Now, the skills. What are the skills you need to become? We've spoken about the mindset, right? Right. Just big English. What it means is it's something to detailed prompting, right? So now we have tools that help you to, it's not everybody that will prompt. There's a way I'll prompt, Copilot to do a code, and there's a way you will do it, and the results are going to be, just see how they will tell you. So for example now, I'm going to tell Copilot, you know what, let me write a test for this component. That's a very bad prompt, right? It's going to do the work, but it's a very bad prompt. A good example is, I have a login form React component, right? Test for failed login, test for success, and then when I submit, test that it does what it's meant to do. That's a very, very detailed prompting, right? The result is going to be different from test this React component for me. Do you get it? So you need to also understand what it means to have a contextual prompting, right? So I'm going to show you some of the tools that help to achieve that. Validation and review discipline, right? You need patience when you're using AI. Do you get? You need patience. If you don't have patience, don't use AI. That's it. Because once it has generated lines of code across multiple files, it means that you need to go to each of those codes and validate them, right? You need to validate them. So it's a discipline. Once you imbibe it, right, just know that going forward, you're going to start building that trust for AI. Context management and knowledge encoding. So when you say context management, like my colleague mentioned earlier, AI has a high tendency to hallucinate, right? Hallucination means that it gets to a point it doesn't know what to do. It does anything that it was told to do, right? You just see that sometimes you give it an error, it will keep giving you the same. But this thing is not working. So at that point, it's for MCP. Speak more about it. So that thing you want to do, right? There's MCP. If you are working on AWS, for example, maybe you want to generate some IAC infrastructure. Your LLM might, if an MCP context management, right? So there are a lot of things that can, of course, thinking in this. You have to be responsible use of thinking in this. You have to be responsible use of it, right? If AI go and bring it for your company, right? Just know that, and by the time the owners come for you, it could be your 1 year salary, right? So there should be a responsible use of AI, and when you are prompting it, don't supply it, very sensitive data like password, tokens, right? I know sometimes when I go on Twitter, some people will say, okay, go to GitHub, just type open AI key, right? You see some people, they have committed their keys inside the repo, so just copy it and help them to use it. So there has to be a responsible use and governance for AI as well. Okay, what are the patterns and the workflow integrations for AI? This is a typical software development lifecycle, right? You're planning, you design, you develop, you test, maintenance. Of course, you can add your deployment to that. So AI across the software lifecycle, you can use AI to brainstorm, right? So let's say you're in a session with your colleagues, 2-3 of you. You want to now brainstorm about a new feature that you're supposed to roll out in a sprint. While your colleagues are doing, no, don't use Kafka, use Rabbit, don't use this one, do that one. Just push your intent, type it there. Before you know it, AI has given you suggestions. So by the time you start talking, they'll be like, they just keep quiet, they'll see you as a genius. Meanwhile, it's AI that is doing the work for you. So design, AI generates design. I'm sure some of you that use Figma today, right? You know that you can prototype fast with Figma. Now, okay, cool. So in testing, of course, you can generate your test cases with AI. AI assisted support. Chat is not giving you the response. What will you do? Carry your phone. Right? So now, it works, right? So, keep mentioned earlier on in all of these pilots, right? So it's not going to replace you. Get the right AI tools in place, right? So these are the patterns of starting to become AI native. You have to get the right tools in place. Learn prompt basics, be specific and provide context, as we mentioned earlier. Use AI for code generation and completion. So those are the steps of getting AI to start working for you. Integrate AI into non-coding tasks. There are still other areas of software engineering that are not coding, right? In fact, one of the things that makes you actually a great software engineer is not just coding, right? It's your ability to plan, do research, design, right? Those are the things that actually make you a great software engineer, right? So integrate AI into non-coding tasks. You can generate. I know a lot of us are very lazy when it comes to writing, describing your PR, right? You just hear fixes. Am I lying? You just hear something like new feature, updates, right? So things like that, AI can actually help you, right? So you just prompt AI and be like, okay, help me to raise the APR for the new feature you've created. To do that, add the text and the description. Boom. Yeah, there. Iterate and refine through feedback, right? So after it has generated what we want to do, you have to iterate, check it, give it feedback. Always verify and test AI outputs. Always verify and trust. Trust but verify, right? Expand to more complex use gradually, right? So that's what the pattern looks like for an AI native. So, of course, what's your name? It's actually loved. It's because of the simplicity. It's actually loved. It's because of the simplicity. Right? When it comes to MVP builders, right, you can use a lot of engineers struggle with it. In my company, a lot of engineers struggle with it. In my company, right, if you raise a PR, and I see LLMs who still don't know how to prompt properly, you understand it to expose you. So they call it specification-driven development. So they brought out a kit that will help you to actually guide AI properly. So AI naturally might go out of context, right? It might do something, the result might not be what you want, but with spec kits, right, you can guide it. You can create a constitution in your code base and tell it that I don't want you to go outside this, right? I want each time you write a feature, generate a test. So what that means is that you have created a constitution for a code base. You don't have to be prompting all the time for you to write a test. It will read your constitution, right, for your code base, and it's going to use it, to guide itself when it's writing. So you can also use it to, create user stories, right? So our advice, you can go to GitHub, search for spec kits. It's going to help your life as a software engineer. So in conclusion, ladies and gentlemen, AI is not going to replace you, right? AI is not going to replace you, but if you don't adopt AI, the person that is using AI will replace you, right? So you are not supposed to move from being a coder, right? From the low-level details, you are now getting to the high-level orchestrator for your code base, right? So I'll just give room for questions. 1, 2 questions, shots. Questions. Okay. Okay. I believe I've not confused you. I've demystified AI a bit for you. Is that it? If you are confused, just wave.
Round of applause. The demystification. So we're going to be going straight into a quick Q&A session, and please.
Well, I'll be asking questions. So LLM stands for. Okay. So now let's go to the main question and all of that. My question is, there is a term called model hallucination. I would like someone to explain model hallucination and how can we prevent or mitigate or reduce model hallucination.
Okay, if I understood what the speaker said, the models, as in large language models, always hallucinate if they don't understand the context of what you prompted it with. So it keeps repeating things or giving you the wrong context, as in content for your contest, giving you the wrong content for your contest.
Go ahead, please.
Okay, so, and he mentioned something about using MCP to moderate it and all that. So that's...
Okay. Thank you very much for that. The guy at the back. Yeah.
All right. For model hallucination, right? Okay. Models would hallucinate if they do not have enough data being provided about the particular context the user is asking about. So the best way to prevent model hallucination is to feed the model with enough data so that it wouldn't give answers that are not even real or things that it does not even know at all. So, yeah.
Okay, thank you. Over there.
Okay. So according to the speaker, or based on what I learned from that session, model hallucination is practically when your model is giving you an answer, even when the model doesn't know the answer. The model gives you an answer just because it has to give you an answer. And one of the ways that he practically showed us how to combat this or work with model hallucination is like using the retrieval augmented generation system, grounding your model with a data source. Thank you.
Thank you very much. You are all close to the answer. I think the closest is, what's your name, please? What?
Nunsi.
Lucy. Nunsi. Okay. So she got it right.
Oh, so she's getting the voucher.
Yeah.
Oh, congratulations.
So you can see me after the events that are here, back-end engineers, basically. So for the second voucher, my colleague Bamidele talked about being an AI native engineer, how to become a better engineer using AI. And he talked about how you can feed it the requirement documents, how it can generate technical specification for you and all of that. And even as a QA, how you can use it to write your test cases. And even designers too can use it. So my question is, if you look at what, if you think about what Bamidele talked about carefully, that means AI will probably be doing almost 80%, if not more, of what you are meant to do. So before AI, you are meant to do everything. You'll be given a PRD, you read it, you come up with your technical specification, you write the code, write README and all of that. But now AI is doing everything for you. And Bamidele mentioned something. So I want to be sure that most of us, we got that part. And my question is, if, for example, as a software engineer, 80% of your work is delegated to AI, so what is the new value that you are bringing? If I want to employ you now, what is that value? What will you be doing as a software engineer, as a QA engineer, since we know that 80% of your work is being done by AI? Your name, please.
With what you said, given the AI doing most part of what you have to do, then it lies on one needing the driver to now drive what you are trying to do. Because when you pick up a business requirement, the core intuition of what's to be done still lies at human, even though most of the execution would be at the AI end. So the key thing is understanding what is to be done, then your capability to now use the available AI tools to then achieve that is where you are needed as a human, figure what the requirement really wants. So with the stack of tools available, then from the design up until, the execution, the testing, even the deployments now with MCPs being created by most organizations. So that's make required. Thank you.
This, you are that, but I just want you to try again. Go ahead.
What AI helps us to do as the lab reduces developer hours, 5 hours, your ability. What I mean by scalability. What I mean by scalability is divisions.
Bebuka. I think what
is divisions.
Bebuka. I think what you are bringing into a workplace using AI. Into a workplace using AI.
All right. And context engineering and architecture. So if AI is going to help you do a lot of these things, you need to be able to know how to prompt the AI. You should be able to structure the architecture in such a way that whatever prompts you are giving to the AI is going to give you the value for what you want.
Thank you very much. There's one person in here. Yeah.
Yeah, thank you. So, based on what you said, right, I feel context programming comes first in this place, and you as an engineer, what you're bringing in is the system design itself. How are you able to design the system effectively? Like, if you give AI garbage, right, AI will give you garbage. But you as an engineer coming in how? You need to kind of build the system architecture very, very optimally and swiftly enough. Thank you.
Okay. The lady, please.
Thank you. So, there are a lot of values from what we've learned, right from the guy that spoke from UK. He mentioned the engines behind AI. And I see that the value that you can bring to any company is your understanding about the engine that is working behind the AIs. And the other value that I see is your knowledge about how it works and the managing of context, how you prompt it.
Thank you.
Okay, based on what I understood, the value I can bring is my management and leadership over AI. He spoke about how junior developers work on like coding tasks and senior developers focus on like system architecture, and how one thing that you can retain from yourself is like understanding the fundamental concepts of like everything you are working on, and how when one key value is the ability to like
that got close to one answered better. AI is doing most of your work. So AI is doing most of your work. So you need to be an architect. So it's like saying, okay, you need to be an architect. So it's like saying, okay, AI can like do something about. So thank you very much. Another one more question. What? Thank you very much. But we didn't really talk about what are they into. What is GPU? And why do we use GPU for AI? And how is it different from CPU?
3-in-1.
Yes, 3-in-1. There's a guy at the back.
GPUs stand for graphical processing unit, and what we use them for is essentially when you think about creating graphics, drawing pixels, it's a lot of triangles, and you need to be able to do them parallel. Yeah, you need to be able to draw multiple things at the same time. Now, what NVIDIA did was, because they are very good at creating GPUs, and they figured out that when you want to do AI and when you want to solve big problems, you want to be able to approach different aspects of the problems without necessarily going one after the other. So what GPUs bring for is that they're able to help you do multiple things, paint multiple pixels at the same time. So GPUs help solve the parallel processing that now makes it possible to do a lot of AI computation. Yeah.
So how is it different from CPU?
CPUs, like CPUs go sequentially. You give it one task, it goes, does the process, and then you're done. But with GPUs, you're able to do parallel thing. I think it's just the parallelity of that whole thing that GPUs help. Wait.
Let's give him a round of applause.
Any other person? Okay. Yeah.
So, like you said, GPU are graphics processing units, and initially they are used for gaming, right? Then for eye rendering, rendering eye graphics, right? So NVIDIA were able to make use of GPU, like you said, for parallel programming, and that's why you have something like CUDA, right? It's a way to utilize the power of GPU to make of those processing power from a GPU. It's more like assembly for the way our computer language has assembly language. So CUDA is more of like for GPU. So it's like the assembly for GPUs. If, for example, many of us know DeepSeek from China. DeepSeek was more influential to like their groundbreaking results at that time was because of their AI researcher and engineer make the best use of the few GPUs they have by learning. They know a lot of CUDA. They know how to deploy that CUDA protocol. They're able to like make use of their the few NVIDIA GPU they could get and get the best result from it. Yeah.
Thank you very much. The fact that you took your time to explain, I like that part. I think we have 2 winners actually. It won't be fair not to give out 2 vouchers. So we'll be giving 2 of them vouchers.
Wow.
So we have 1 left, and another warm-up question. There is a term called ACID in database. What is ACID? Emmanuel, senior engineer.
Thank you, sir. Good afternoon. I'm Emmanuel by name. ACID is the acronym for Add, Change, Inspect, and Delete in database.
ACID principles.
You mean the acronym?
Yes.
Add, Change, Inspect, and Delete.
Okay. Can someone else try?
Is it raising your hand or you're raising it by yourself?
Okay, for the acronym, A is atomicity, C is consistency, I is isolation, and D is durability.
Thank you very much.
This your warm-up question is even hard. I don't know what the question will be like.
I think I have another warm-up question. Warm up. What testing approach involves writing tests before writing the actual code? The guy at the back.
It's called TDD, Test-Driven Development.
Thank you very much. So for the last voucher, we have a lot of software engineers here, so I'll make it harder. It's very simple, we all know it, but I just need you to explain it in layman terms. So assume that we are not engineers, or we are like 5-year-olds here. So I need you to explain solid principles. Solid principles. So you give me example, like explain it to me like I'm 5. Solid principles.
No hand is up.
Software engineers, front end, back end. I don't want to call names though. Solid principles.
Okay.
Okay, I want to try. So the S stands for single responsibility. Should I explain everything or just the acronym?
Yeah, explain.
Okay, so the single responsibility means that a function should do one thing and should not do many other things, basically. The O means...
Sorry, please.
Okay.
I'm 5 years old. I don't know what
the function is. So so explaining solid principle and the S meaning single responsibility means that if I'm saying I'm going to buy something, my goal is to go and buy something without doing any other thing along my way to buy that thing. So my focus is to go and buy that thing. So if I'm going to create a function that is to maybe to create an alert, that function should only do that particular thing and not do any other thing else, because I can want to use that function in other places so as not to complicate things, basically. So for the O, I'm going to that function to extend. Then for the L is list of the non-expression one for now. Things too tight.
Should this? First of all, like they were saying here, it's not meant for 5-year-olds, but we'll try. Okay, so solid principles, basically how I would explain it to a 5-year-old me. A 5-year-old me is only worried about building toys. So we want to build a train and we want it to last, right? We want it to be maintainable such that I can clean it, adjust it, and make it work efficiently for me. But as a 5-year-old, drive it around my house and play with it. And if I want to add new coaches to my train, I should be able to add it without having to destroy it all over again, because I don't want to lose pieces of my Lego blocks. So it starts with that mentality that since we want to build a train that is very nice to play with, won't crash by me just touching it, then we want to do something that even if I'm going to change it, right, it should be because of just one thing that it's doing. My train is just worried about going around the house on my train tracks. So if I'm going to change it, then it should be that, okay, does it want to go faster, or do I want to extend the coach by adding just one more coach behind it? So basically the S, like he was trying to explain, because I'll pick some of the things he was talking about, right? That's something, right, should only have one function, right? And a car only has one function, drive me around. So maybe my train has only one function, give me pleasure anyway, because I'm a child. That's the only thing I'm thinking about. So I want to drive my train around, and the only thing it does is go around and I make sounds for it. So if I want to add I've forgotten what sounds, it's easy for me to as to, you can only extend train to house, because my train is built of Lego blocks, and that, in this case my train is super. I'm trying to not to use the big words. Dependency injection here is the engine. You can just start those, right? My on is going to crash, because well, it's like putting the cart before the horse. And one of the other principles, in this case, if I want to create, and one of the other principles integrated. In this case, if I want to create another version of a train, so create another version of a train. So okay, my friend comes and say, oh, I don't like that, and create your own type. And you can, I don't know, borrow it to the way I usually explain to myself before I be going to any interview. I would say that it's as similar to basically a bigger. So right. So for a subclass, he said doesn't like my own version. He wants them to be 8. So I can create a subclass from this my own base train for him to build his own. Right? I begin again and problem starts. So that's basically it. Thank you.
Thank you very much.
Our time is up. Sorry. I'm missing beats, but I think I understand that better. A 5-year-old meets, but I think I understand that better. A 5-year-old me understands what she's trying to explain.
$500 or you said something like that. $500 or you said something like that. You just denied me. Wow. I thought he said 5, so my mind was thinking $500 or something. Because that young man corrected me that in tech we deal with USD. I should stop using Naira. So it's 5. Don't worry, you will get the voucher, but it's fine. We're good. So we are going on a short water break or tea break, as you call it. So we can just connect as well, mix with people, look for a familiar face, someone that is looking serious. You can just give him a jab or something while we continue. So it's a break, like a 10 minutes break before the next session. But while we're still having the break, I have some new faces in here, and I started with a question earlier, and I will still go back to the question. It's not a serious session, it's just a break. And I asked the question about common misconceptions in your job, in tech. And I remember the first 2 things some people said. A guy there said something like, everybody thinks you are very smart when you're a developer. And he said it's a misconception. You may not be smart. Someone else said something like, if you're a developer, everybody thinks you are very rich. And it's also, it's a misconception that you are not very rich. Even though my guy here confirmed he's very rich. He's heading towards like 4 point something million USD thereabout. I'll just cover him up. So I will go to some people, you will tell me one thing you love about your job, and a common misconception that you've experienced over time in your job. Maybe you've been arrested before, I don't know, you can tell us, and then a policeman will just look at you. There's something fishy about you, even though I don't know it. I don't know, you can just tell us. So I know you know I'm coming to you, but it's fine.
Good afternoon. I think for everyone, it's just practice. You keep practicing. You get to say, because I'm a front-end engineer. So when you actually convert those UI designs by the designs from the UI design.
Thank you very much.
Okay, yeah. So one thing I love about my job is that it involves common misconception about my job is that we count real life money, but we don't see them. That's it. Thank you.
Thank you very much. I'll take one more. Please let me pass the mic to him.
Okay, so what's the question about? Sorry, what's the question about? Sorry, I wasn't following. Okay, it's conversation about my job. Okay, one thing I love about my job is flexibility. It's very flexible because I can't remember the last time I went to the office. For the past 2 years, I've not gone to the office, sorry. So it's very flexible. That's one thing I love about my job. Then for misconception, like what I think someone said earlier, they see engineers as a very rich kind of person, you get, right? So if you I never read that stage. Aspiring, so I'm getting there, but I'm okay. I'm okay anyway. So so if you tell anybody that okay, I'm a software engineer, and I say well, you get money, you sure you understand, and that is a misconception. That's not true. And you know that Nigeria software engineers in Nigeria are actually underpaid. Yet they are underpaid as a software engineer in Nigeria. So it's something we need to like really look out for, something like need to like, okay, I don't know how we can do it, but software engineers in Nigeria are underpaid.
All right, thank you very much, everyone. So we will resume the third talk in 10 minutes. All right, thank you. So we can connect, we can hang out, and we'll be back in 10 minutes on the dot. Thank you.